In this lesson, you're going to learn to find the perimeter and area of triangles and trapezoids. If we look at the formula for the area of a triangle, you will see that it is 1/2 the base times the height. For the area of a trapezoid, it is 1/2 times the height times the both bases added together. That's because if you think about it, a triangle or a trapezoid can be thought of as half of a parallelogram. Perimeter we're still going to find the same way we did in our last lesson. To find the perimeter of each figure, we're just going to add the sides together. So in this case, for this first one, we're going to take 10 plus 7 plus 4 and add all of those together. When we do that, we get 21. So the perimeter of this first figure is 21 units. Again, to find the perimeter of a trapezoid, all we're going to do is add all the sides together. So we're going to have 17 plus 6 plus 11 plus 8. When we add those all together, we get 42. So the perimeter of B here is 42 units. For these next two, pause the video and try these two by yourself. Sometimes you may be given the perimeter and you need to find the length of a missing side. How you would do this is you would start off with adding up the sides that you do know. In this case, we have a 22, 18, and 15. If we add those together, you will get 55. Now, to find out what that missing side is, what we're going to do is we're going to take that 71, which is the total perimeter, and subtract what we already know. And what we're left with, in this case is 16, is the length of D. So D is 16 inches. Now try the next problem on your own. Alright, now comes some application, how we're going to use these problems. In this example, we have that a homeowner wants to plant a border of shrubs around her yard that is in the shape of a right triangle. She knows that the length of the shortest side of the yard is 12 feet and the length of the longest side is 20 feet. How long will the border be? Find the length of the third side of the triangle using the Pythagorean theorem. The first step I like to do in any problem is I will start and draw a picture of what I know. So we're going to draw a right triangle. What it says that we do know is that the shortest side of the yard is 12 feet. So we're going to go ahead and label that. But here it says that the longest side is 20 feet. And if you remember about the properties of a right triangle, the longest side is always going to be the one opposite the right angle. So that's going to be our C, or our hypotenuse, is going to be the 20. So if you remember, our Pythagorean theorem says that a squared plus b squared equals c squared, where c is always opposite the right angle. So we're going to have 12 squared plus b squared equals 20 squared. 12 squared is going to be 144 plus my b squared equals 400. Now, to solve this, we're going to subtract our 144 from both sides. When we do that, those cancel out. I'm going to be left with a b squared over here, and 400 minus 144 is 256. Now don't forget the last step of solving an equation like this is we have to do the opposite of squaring something, which is taking the square root. So take the square root of both sides, and we get b is equal to 16. Now we know the lengths of all the sides. So to find how long the border is going to be, all we have to do is add all those sides together. So I've got 20, because it's going to be the perimeter, 16, and 12. When we add those together, we get 48. And in this case, the label is feet. So it would be 48 feet. Okay, now you can try this next problem on your own, but let me help you out a little bit. It says a gardener wants to plant a border of flowers around the building that is in the shape of a right triangle. He knows that the length of the shortest sides of the building are 38 feet and 32 feet. How long will the border be? Again, we're looking for perimeter. So start off with drawing your right triangle. And it says that the shortest sides are 38 and 32 feet. Remember, the longest side is always opposite the right angle. So 38 and 32 are going to be the other sides of the triangle. So remember, this opposite side is always the longest side, which is going to be your C. Now finish the problem on your own. Pause the video. Alright, now we're going to graph and find the area of a figure with the given vertices. Remember, vertices are the points, the corners of the figure. So let's try and figure this out. Let's graph these. Remember, when we're plotting our points, the X, or the left or right, is first, then the Y, or the up and down, is second. So -2 means we go to the left 2, and then up 2. Over 4, up 2. And we don't go anywhere on the x-axis, and up 5. We only have 3 points, so we know that this is going to be a triangle. So now we'll go ahead and connect those points. We have our triangle drawn here now. Now to find the area, you have to remember, what is the formula for finding the area of a triangle? Remember to find the area of a triangle. Area equals 1/2 the base times the height. So we've just got to figure out what's my base and what's my height here. The base, we'll just say, is the bottom here. And if you count how many squares, you get 1, 2, 3, 4, 5, 6 squares. So the base is going to be 6. Now the height, remember, is going to be what's perpendicular to the base. So the point where it's perpendicular here is right there. Going right up the axis, we can count how many squares that is, and that's 1, 2, 3. So the height is going to be 3. So to find the area of this figure, we're going to take area equals 1/2 the base, which is 6, times the height, which is 3. So area equals 1/2 of 6, which is 3, times 3. So area equals 9. 9 units. Now let's try another one. Here we're given some other points. We're given 4 points, so we know it's not going to be a triangle. So let's go ahead and graph these points and see what we get. We have -1, -2, 5, -2, 5, +2, and -1, +6. It's going to be right there. Now we're going to go ahead and connect those dots and see what figure we have. When you're looking at this, what this is going to be is this is a trapezoid. But you've got to be careful because our bases, remember, are always parallel to each other. Well, which lines are parallel to each other? We have this line and this line that are parallel. So those are going to be our bases. So let's find out what is the length of our bases. We're going to go ahead and count. We've got 1, 2, 3, 4, 5, 6, 7, 8 over here, and 1, 2, 3, 4 over here. Now our height, remember our height is going to be perpendicular to the base. So we've got to figure out where is it perpendicular to the base. Well, it's perpendicular to the base. Right here it makes a 90-degree angle. So that's going to be our height. So our height is going to be 1, 2, 3, 4, 5, 6 units. So now all we have to do is fill them into this formula that we're given. We've got area is equal to 1/2 the height, which we know the height is 6, and base 1 plus base 2. So area equals 1/2 of 6 is 3 times 8 plus 4 is going to be 12. And 3 times 12 is going to give us 36 units. So the area of this trapezoid is 36 units. Now go ahead and try this exit ticket by yourself. You need to find the perimeter of the triangle, the perimeter of the trapezoid, the combined figure, which means you're just going to add all the way around the whole figure, and then the area of the triangle and the area of trapezoid. When you're done, bring it to me to check your answers.